Okay, so welcome back, guys. We're in lesson 4. This is word problems for systems of equations. So we kind of already practiced setting up word problems a little bit, but today we'll get more into that. And before we do, we want to just kind of review some of the things that we've already done. So some of the things that we've already done, we've tested equations with points to see if those points or those ordered pairs are solutions of systems of equations. So that's one of the first things we're going to review. And then we're going to solve a system by graphing. So we're going to identify whether or not two equations have an intersection or more than one intersection. Then we're going to check to see if, like, we're going to use substitution to solve systems of equations. That's part of the review, as well as elimination. But let's go ahead and get started. So first, when we're deciding whether the ordered pair is a solution of a system of equations, we need to identify an ordered pair. So let's just rewrite the ordered pair. It's 2, -1, and this is x, and this is y. And so what we're going to do is we check each equation to see if this coordinate 2, -1 makes equation 1 true, and it makes equation number 2 true. So equation number 1 is 3x plus 2y equals 4, whereas equation number 2 is -x plus 3y equals -5. Now we plug the numbers in. We have 3 times 2 for x plus 2 times -1 for y equals 4. And remember, we always put a question mark here to test. We're testing the truth of this equation statement. Well, 6 minus 2, does it equal 4? Question mark. Yes, this is true. So 4 does equal 4. I can put a little check there. Now, for the second equation, we have -x, so that's going to be -2 plus 3 times -1 equals -5. This is -2 minus 3 equals -5, and for this particular equation, the coordinates are true. So I have a little check here, and so my answer here would be yes. 2, -1 is a solution. Now, let's check the second part. We have 3x minus 2y equals 4 is my first equation. -4x plus 3y equals 5. And this is x, this is y. Plugging the numbers in, 3 parentheses 2 minus 2 times -1 equals 4. 6 plus 2 does that equal 4? 8 does not equal 4, so this is false. There is no check mark. And let's go ahead and check the second one, just for practice. -4 parentheses 2 plus 3 times -1 equals 5. -8 minus 3 equals 5. -11 does not equal 5. This is false. So since we have false and false, we're going to circle no. That is not the solution to that system. Okay? Now, the second step is graphing equations. So if you don't remember, I told you before, we want to create tables of values for y equals 2x, and then I'm going to graph those points, and then I want to create a table of values for y equals 7x minus 5, and then I'm going to graph those points. So what we'll need here is our graphing calculator. I'm going to hit the graphing calculator and pull it up. Okay, unfortunately, my graphing calculator is not working for me right now. So you're just going to have to trust me and follow my directions. So you go to y equals. You go to y1, clear out whatever equations there. Type in 2x for your first equation. You press second graph and record the points in your table. I have -2, -4. You might not start at the same place that I do, but that's fine. Just make sure that some of the points that you obtain are graphable, right? So graphing the first point, I go left 2, down 4. So left 2, down 4, and I graph my points. I go left 2, down 2. So left 2, wait, left 1, down 2. Left 1, down 2. I go stay and stay at 0, 0. This is a direct variation because we go through 0, 0. I go right 1, up 2, and graph a point. Okay? And I'm going to graph my equation. Remember, we don't want the crooked lines, if possible. Now, for my second equation, you go back to y equals. You clear out 2x. You type in 7x minus 5, second graph, and we record points that we can graph. I'm going to start at 0, -5, 1 and 2, 2 and 9. So stay and go down 5 at 0. I'm going to go right 1, up 2, right 1, up 2, and I found my intersection, and I'm going to create my line. So there is an intersection here. The intersection happens to be right here at 1, 2. So my solution is 1, 2. Next, we're going to solve by substitution. The first step in doing this is labeled in the equation, number 1 and number 2. And then we're going to figure out what we're substituting. We're substituting x plus 7 into what y equals. Okay? So when I rewrite, I have 2x minus parentheses equals -5. Remember, I'm replacing y, so I'm going to write x plus 7 in here. Now, what happens when first we distribute? Okay, we make sure we don't have to distribute, and we do. So this negative changes the sign of everything inside of this parentheses that I'm outlining. If x is positive, the negative causes it to become -x. If 7 is positive, the negative causes 7 to become -7. Now everything else, it just comes down when we're solving for this variable. Okay, next we simplify and combine like terms. Our like terms here are 2x's and 1x's. So 2x's minus 1x is 1x. -7 comes down, equals -5 comes down. Add 7 to both sides. And x equals +2. Now I only have to find y. I go back to my original equation, y equals x plus 7, and I substitute what x is in. 2 plus 7 equals 9, so y equals 9. So my solution is an ordered pair. We're mapping x comma y onto 2 comma 9. Okay? So far you guys have been doing a really good job with this. So I am definitely impressed. Now, solving by elimination, we label our graph. We look for, this is what our look for is here. We look for an x and y on the same side of the equal sign. Check equation number 1, equation number 2. That's true. We look for variables with the same coefficient. That would be x. And then we look to see if those coefficients are opposites. And they are. So we're in a good place here. So when we're eliminating, we draw our line underneath. We go left to right each column. And we solve. We eliminate one of those variables. Here, we eliminate x. But 2y plus 6y is 8y equals -24. We divide both sides by 8, and y equals -3. Now I only need x. So I'm going to go back and pick an equation. I'm going to pick x plus 6y equals negative 16. Say x plus 6 times negative 3 equals negative 16. X minus 18 equals negative 16. Add 18 to both sides of this equal sign, and x equals positive 2. So when we're writing our mapping, we say x comma y maps onto 2 comma negative 3. Now, next, what is the solution to the system that is graphed? Well, I can identify this coordinate. I go left 2, so negative 2, up 3, and there's my coordinate. So we could write x comma y maps onto negative 2 comma 3. And there's your warm-up. All right? Thank you, guys. So there's two separate videos here. This is the first part of the video. The next video is actually lesson 4. Have a good day.